Hi there, in this video I'm going to be giving a demonstration of batch processing Bruker MRMS or ICR files in AutoVectis. So we'll be starting with the transients and going all the way through batch phasing, batch assignment, in this case of dissolved organic matter, right the way through to producing a single database file combining all the outputs in one. Step 1 is batch phasing. That means a workflow that automatically converts an entire folder full of Bruker files into absorption mode mass spectra. And so we do that using the AutoVectis module. Inside AutoVectis, our first task is to phase a single file in that folder. AutoVectis contains lots of controls, giving you lots of functionality, but in the vast majority of cases, you don't need to change them. You can just let AutoVectis set them automatically or use the default settings. The only ones you might change regularly are the mass range, but in this case, the mass range that was left from the previous file is already correct for dissolved organic matter, so we'll just leave it as it is. So all we actually need to do is hit begin. I'm letting this section of the demonstration run in real time, so AutoVectis will load the spectrum, automatically identify the peaks, which we'll accept, and then automatically detect a region to use for brute force phasing, which again we'll just accept. Then AutoVectis uses its genetic algorithm to extend that initial phase correction function over the complete spectrum, and then we can detect the peaks in that absorption mode spectrum. And that's now complete, so we can zoom into the detail of the absorption mode spectrum. The magnitude mode spectrum is shown in red, the absorption mode spectrum is shown in green, and the peaks are shown as yellow centroids. Having successfully phase corrected one of the files in the folder, we can now go ahead and set up the batch process to automatically phase all of the others. And to do that, we need to jump to the Batch Process tab, and then select Phase All Files in Folder. First, we need to identify the folder that we're going to batch phase. And then AutoVectis will identify all the files in that folder that we could edit, but here we'll just batch phase the entire folder. Down here we could change the phasing mode, but here we'll just keep it in the default setting where it will use the current phase correction function as the basis that it will then re-optimize for all the files in the batch. So all we really need to do is hit Run Batch. For every file in the batch, AutoVectis will automatically load the spectrum, detect the peaks to be used for phasing, apply and optimize the phase correction function, detect the peaks in the absorption mode spectrum, and then save that AFT spectrum and its peaks to a file. And then it will move on to the next spectrum in the batch. Once the batch is running, you can go off, get a cup of coffee, or catch up with your emails, or just leave the process running in the background. You can keep track of how many more spectra there are on the batch using this indicator here. If you wish, on the Phasing Excellence tab you can keep a track of how well each spectrum is being phased using this graphical output. You want to see all of the red points which correspond to each individual phasing peak being clustered around the final phase correction function, which is the blue line. The MS Image tab contains a table which shows the phase correction function and a figure of merit indicating the success of phasing for every file in the batch. After the batch process is complete, the contents of this table are saved to a file, and you can use that file to quickly check and see whether there's been any issues with phasing any of the spectra in the batch. I'll just speed up the last 45 seconds of the batch. So we now have 0 files left to process, and the batch is complete. If you discount all the times that I paused the processing just to explain what was happening, or sped it up because it was boring for you guys to watch, then it's actually only taken 4 minutes 36 seconds to go from having a completely unprocessed folder to having 10 absorption mode spectra that have been processed with no prior knowledge of the phase correction function or the QMP as it's known in the Bruker software. So that means we can close down AutoVectis and move on to the next stage in the processing workflow. Step 2 in this automated workflow for batch assignment is the batch recalibration. And for complex spectra like dissolved organic matter or metabolomics, this tool can be found in Autologous. You start the batch recal tool by clicking here. Identify the folder of files that you want to batch recalibrate. Then identify a list of potential ionic formulae that could be used for recalibration in those files. You can test individual files to see if you have the parameters correct in order to undertake recalibration. In this case, it looks like the instrument calibration was a bit further off than we expected. It looks like for this batch of files, if we look within a 10 ppm range, we should be able to batch recalibrate them all. So we start the batch by clicking Run Batch. You can track the progress of the batch process down here. As each file is processed, its recalibration function will be shown in the graphical output. I've sped up the last minute of the processing just to get through it faster. The batch recalibration process has now completed. And before closing down the tool, AutoVectis will save a text file and an Excel file containing the parameters of recalibration for each file. Again, I played around with the speed a few times in this demonstration, so sometimes I paused it in order to explain what was going on, and at other times, as you saw, I sped it up. But this batch recalibration process took only 2 minutes for all 10 files in this folder. So now we can move on to the next stage in this automated processing workflow. For this demonstration, we're going to assign the files in this batch using the inference method. That means that for each file in the batch, we're going to identify the mass differences between peaks that correspond to known homologous series. And then we'll connect those together to form a network that will allow us to infer the formula of an unknown peak from the formula of a known peak that is connected to it. We've already assigned the peaks that we use for internal recalibration, so we can use those as starting points to assign all the unknown peaks in each file. And we can repeat this process for every file in the batch. And we start the batch infer tool by clicking here. First, we have to identify the folder that we want to batch process. The files in that folder are shown here, and as normal with this type of display, we could edit this list now so that we only batch process part of the folder, but we'll leave it complete for this demo and batch process the entire folder. Autologous contains mechanisms for automatically identifying potential contaminants in the data, but we'll turn that option off for the purposes of this demonstration. We do need to identify the list of potential homologous series that the system will use to develop the linkages in the inference network for each file. There are a number of different ways that you can supply this list. You could type the links directly into this box, or you could copy and paste them in from a text file, or as we're going to do here, we can upload them from a previously processed data file. And the last thing we'll do here is define the type of ions that we expect to see in the file. For the purposes of this demo, I'm not going to change the maximum and minimum allowable stoichiometries, the mass error range for assignments, and nor will I turn on the requirement to fit the isotopic fine structure of any results. So instead, all we need to do is hit Run Batch. And then for each file, Autologous will generate the inference network, and then begin to assign all the peaks in the file through that network. Once each inference network is fully assigned, Autologous saves the file and moves on to the next file in the batch. On my laptop, it took just over 4 minutes 30 seconds to assign all 10 spectra in this batch, but we want to get on to the next stage of the batch processing, so I've sped that up 8 times just to get through it a bit faster. Once the batch is complete, Autologous will close down the batch inference tool and take you back to the main menu screen. You can review the results of assignment for each individual file in the batch by clicking View Results. But if you're dealing with an entire batch of files, then it may be more useful to try and combine all the results into a single file. That way you can see how the intensity of each individual component varies across the batch. Or if you need a single table of results to input into a machine learning process. The Batch Results tool will allow you to combine all the results of a batch into a single SQLite database file and to a single Excel file. And you start that tool by clicking here. As is usual with the batch tools, the first task is to identify the folder containing the batch you want to process. And as normal, you can edit this list, but again, we'll keep it complete. So all we have to do is hit Run Batch. Now you have to identify where you're going to save the output database, and the Excel file will also be saved with the same name in the same location. You can track the progress of the file creation down here. First, the system loads all files so that it can generate a unique list of components that covers all components across the complete batch. Then it saves the combined results table and all files into the database. Finally, it creates and saves the Excel version of the data. And that's it, your entire batch has been processed into both an SQLite database and an Excel file that you can use for data review or onwards processing. So, I hope this demonstration of the batch processing capabilities in AutoVectis has been interesting. I've successfully used this workflow to process batches of over 200, even over 300 Bruker files in one go. If you have any questions, you can of course contact us at autovectis@gmail.com, or you can speak to a member of the SpectraSwiss team.